Assalamu alaikum. Welcome to my channel Process Simulation. And today in this video we will look into the minimum wall temperature or wall temperature. How can we determine the wall temperature from HYSYS using the depressurization or during the depressurization? How can we get the minimum wall temperature or wall temperature? The significance of this is that uh, the term called MMT, minimum metal temperature, and that as a process engineer we have to define from the process point of view what will be the minimum temperature that the metal will see. Okay, and so in that purpose, we have to do the depressurizing analysis. In depressurization, there are three parts. The one is called fire, one is called adiabatic, and one is called low temperature depressurization. I'm not going to go in detail what is fire and how what we do first, what we do second. But today I will go on a example uh, just to show you how can we get the temperature value. What's the methodology for that, and that we will have a separate video for that. In which we will take a case study and we will study the first fire and all those things. Okay. So I have a here one gas composition. 40 number stream as you can see. Temperature is 138. It's quite hot, and then the pressure is 11 psi. And we will make something like that. We will go and depressurize this. So for this application, I am considering a vertical vessel. Since I have that example that is in my mind, and that's why I'm putting it like this. Yeah, that's why I'm putting it like this. I put some 1.7 meter, uh, and then we have. I remember, I think it was somewhere 6 meter cube. So I will put that there. So moving forward, I'm putting the initial liquid level as 0. So main important thing is that is the heat transfer. So if you go heat transfer, we have to first select the adiabatic. Okay. And in the second thing, we have to select the detail. We have three options: none, simple, and detail. In none, you can have nothing. In simple, you have the ambient temperature input only, and detail is one where you put all thicknesses of the metal. Metal thickness is required. So the ambient temperature, I'm going to put 8 degrees C. Thickness, I remember it was around some 15 or 12 mm. And insulation, you have to remove. You have to remove the insulation. So if you put the insulation, then it will not take the credit of the ambient temperature. Let's move forward to the next step, that is well parameters. So in well parameters, we will go and put journal, and we will put the CD factor of you can say 0.6, 0.8. It's up to enter. In option, this is PV work done, and the maximum you put the minimum temperature you get. So for the operating condition, I remember it's adiabatic, so I will put some around 30 minutes for that. And I remember the arrows, the area was from the fire case was somewhere little to 150 square, and then we will run it. So the software has given some errors. I'm not going into detail that how the depressing utility actually work, but the intent of this video is to show the relation of the heat transfer module. Selecting the correct heat transfer module will only give you the wall temperature. So in heat transfer, you have to select the detailed with the thicknesses of the metal, and then only in the performance tab you can get the inner wall temperature. And the inner wall temperature is very important for you. The reason being is that if you see the fluid temperature and inner wall temperature, regardless of the numbers, I'm giving you the real life thing. The difference is mostly around 10 degrees C. So if your minimum vessel temperature is around -10, your inner wall temperature will be 0, 1, or maybe positive 1. So there's the importance of having this inner wall temperature. If it is your vessel fluid temperature is very near to the -28, that's the limit for the CS carbon steel and low temperature carbon steel, you can go and select low temperature carbon steel. But if you didn't put the heat transfer things, and you didn't put the thicknesses of the metal, and you didn't get the inner wall temperature, maybe your inner wall temperature is not -10 or -11. So in that case, you will end up spending too much on low temperature carbon steel. As you know that metallurgy play a very big role in capex estimation. So we have to make sure that we are not designing something very conservative. Um, this is just this video. The intent of this video is just to show that how to get this inner wall things. Because if you go to simple now, you will not get this inner wall things, and it will take a very flow. So in next video, inshallah, we will do a case study. We will do a solved example, and we will go in step by step each methodology, how to select the ROIs, what is fire, why fire has to run first, then what is adiabatic, then what is low temperature adiabatic, what is the chronic effect. I will go each in bit and piece in detail in the next video. Thank you.